Plastic pollution is one of our most pressing environmental challenges. The United States alone is the #1 plastic polluter per capita, yet we recycle only 5% of our plastics. Most recycling technologies simply melt down plastic bottles and downcycle them into lower quality products. But what if there was a better way? Scientists at Northwestern University have developed a groundbreaking approach that could revolutionize how we recycle plastic. Their method doesn't require toxic chemicals or harsh solvents. Instead, it uses something remarkably simple: moisture from the air around us. The team, led by researchers Yossi Kratish and Tobin J. Marks, has discovered a way to break down polyethylene terephthalate, or PET, the most common polyester plastic used in water bottles and food packaging. This plastic makes up approximately 12% of all plastics globally and is notorious for persisting in the environment, ending up in landfills or fragmenting into dangerous microplastics. Here's how their innovative process works. They combine PET plastic with a low-cost, non-toxic molybdenum catalyst and activated carbon, then heat the mixture. This initial step breaks apart the large plastic molecules. Then comes the ingenious part. They expose these fragmented plastics to ordinary ambient air. The trace amounts of water vapor in the air trigger a chemical reaction that converts the plastic fragments into terephthalate acid, or TPA, a valuable building block that can be used to create new polyester products. The only byproduct is acetaldehyde, which is relatively easy to remove in industrial settings. Air contains a significant amount of moisture, making it a readily available and sustainable resource. Even in relatively dry conditions, the atmosphere holds about 10,000 to 15,000 cubic kilometers of water. The results are impressive. In preliminary trials, 94% of the TPA was recovered in just 4 hours. The catalyst proved to be robust and reusable, making it practical for large-scale applications. And because the technique selectively breaks down only polyester plastics, it can be used effectively, even with mixed plastic waste. What's particularly exciting is that when tested on actual plastic bottles, shirts, and mixed plastic waste, the process worked equally well. It even eliminated dyes, producing colorless recovered TPA that can be used to create new products. Traditional recycling methods often require extreme temperatures, high energy input, and strong solvents that generate toxic byproducts. They also leave behind a soup of materials that require extensive sorting to recover useful components. In contrast, this solvent-free approach is what Kratish calls a much more elegant way to tackle plastic recycling issues. The next step is scaling up the method to meet industrial demands and handle larger quantities of discarded plastic. By optimizing factors like reaction time, catalyst concentration, and temperature, the researchers hope to create an economical solution for converting waste plastics into valuable building blocks. This technology represents a tangible step toward a cleaner, greener future, and demonstrates how innovative chemistry can address global challenges in a way that aligns with nature, turning one of our biggest environmental problems into an opportunity for sustainable materials production and a truly circular economy for plastics. For more on this story, find a link to the article on Earth.com in the description.